Amorepacific has been based on its current Yongsan site since 1956, when the company was known as Pacific Chemical. In 1976, the company completed a 10-story office building on the same site. After decades of growth, Amorepacific became the leading cosmetics company in Korea, with many brands and affiliates. As the company expanded, Chairman Bae aimed to make Amorepacific a global company. To support this goal, the company needed a larger and more integrated workplace, where employees and affiliates could work together more efficiently. For this reason, the old Yongsan building was redeveloped, and the new Amorepacific headquarters was completed on the same site in 2017. Employees moved into the new building from late 2017 to early 2018. Hello everyone, this is Team3 HY². This project was undertaken to construct a new office building to renew the old office building on the existing site. To achieve this goal, the client Bae commissioned the work to David Chipperfield through a competition. Since the building is located in the center of the Yongsan, the goal was to have a unique exterior that suits the character of the location. And this building had to not obstruct the movement of users at the existing site. For the inside, they considered ways to maintain a sense of spaciousness and understated elegance. Additionally, they designed a central courtyard to enhance users' work efficiency and community while fostering a daily satisfaction. For the next step, we moved on to the design concept and the architect's intention behind this unique architecture. First, one of the main design concepts of this building is the courtyard structure, inspired by the traditional Korean house hanok. This courtyard can make a space where it's open to the sky, bring natural light and ventilation, and also where people can gather. The concept of the traditional hanok courtyard was reinterpreted into the design of Amorepacific building. The second concept is the exterior design inspired by traditional Korean white porcelain called baekja. The bright and simple facet reflects the elegant and pure beauty of white porcelain while expressing Korean identity through modern materials. In this way, the Amorepacific building is a good example of harmonizing traditional Korean elements with modern architecture. The facade and louver design are inspired by the traditional Korean choma. In traditional architecture, the choma provides shade and protects interior spaces from excessive sunlight, while allowing natural light and air to enter. This concept is reinterpreted in the Amorepacific headquarters through a vertical louver system, which blocks direct sunlight and reduces heat gain while bringing soft, indirect daylight into the building. How exactly did David Chipperfield's ideas get translated by the engineers? From this point on, we will explain the key innovative construction processes and the innovative engineering methods applied on site to realize this structure. First is the CIP method. Because subway line 4 runs right next to the site, even slight ground movements during excavation can affect tunnels and tracks. To prevent this, a dense underground concrete pile wall was built before excavation to control ground subsidence, vibration, and construction noise all at once. We will now explain the construction method. To prevent the soil wall from collapsing during the excavation process of the indicated section, the CIP method is used. A guide is installed at the earth retaining target area. Then, excavation is performed with a drill machine. Then the casing is inserted. H-beams, which will bear the lateral earth pressure, are inserted. Rebars are inserted to enhance the shear stiffness of the wall. After inserting, the concrete is poured, and the casing is removed. Finally, the upper guide beams are removed to prepare the excavation. This scene illustrates the structural support method where the outer CIP pile wall and the internal first floor steel frame horizontally interlock with each other. These CIP piles serve as the strongest structural foundation from the perimeter, ensuring that the frames and slabs can be stably seated and supported during the upcoming top-down process. Second, let's look at the top-down method. For this massive 7-basement excavation in the heart of Yongsan, the site was extremely limited, with very little room for conventional construction work. So, instead of digging everything first and building from the bottom up, the B1 floor slab was cast early in the process. This slab worked like a temporary cover, helping to trap noise and dust inside the site and reduce impact on the surrounding city. At the same time, construction continued in both directions. Excavation moved downward while the upper structure was built upward. This simultaneous up and down process allowed the project to save time, improve site efficiency, and overcome the tight urban constraints of the Yongsan location. Let's move on to the next construction method. First, holes are bored into the soil ground using a drilling rig. Steel columns are deeply installed to support loads. This is the internal view of the columns. Next, we will show you the process through a cross-sectional view. Initial excavation is carried out to secure space for pouring the first floor slab. The foundation framework is laid down. Afterward, the downward excavation process. Following the excavation, the first floor slab is poured over the assembled beams. The lower basement levels proceed sequentially in the same manner. Upon excavating down to the third basement level, the concrete core structure begins building upward for the superstructure framing. Then, excavation resumes downward. From this stage, the actual top-down method unfolds, with core lifting above and downward excavation below. With the basement pouring completed, construction process to superstructure. Third is the megatruss method. To maximize openness in the community area, plan a massive void and boldly eliminate internal columns. Instead, a megatruss was installed to safely distribute the heavy upper load to the building's cores. Because of this construction method, the architect could remove columns from the void space and create a more open community area. As a result, users can experience a wider, brighter, and more spacious environment inside the building. Now, we will show the construction process of the ground level structure. Cores and columns rise one floor at a time. Next is the bracing. Supported by the core, diagonal bracings are installed to support the void spaces. Here is the result. Moving on to the next, columns and beams go up with the core. At the top level, the megatruss is installed. Then, the plates are placed. The slabs are constructed sequentially from the upper floors to the lower floors. Through this process, the construction of the building is completed. Amorepacific building is highly characterized by its massive central void, which maximized visual openness. This open structure not only boasts stunning aesthetic, but also serves as a vibrant community space where employees can gather and interact. Architecturally, it looks absolutely flawless. But is it really without flaws? While this structure is excellent for making community We saw that the broken circulation would ultimately cause significant inconvenience to the users. We precisely simulated the internal circulation traffic using the architectural analysis tool, Grasshopper. The results confirmed our hypothesis. The pedestrian traffic heavily converged onto limited pathways in specific zones. It caused severe bottlenecks, essentially a form of internal traffic congestion. Since computer simulation data wasn't enough to be entirely certain, we headed directly to Amorepacific building. We conducted a user survey targeting the actual employees who navigate this space every single day, both inside and outside the building. Did their thoughts match our analysis? Based on the sticker votes, we verified the results based on the survey results provided directly by people. First, regarding community formation through the central garden, 79% of users responded positively, confirming that the communication space is well activated as intended. For the internal circulation, which forms a ticket shape due to the structure, a staggering 73% of actual users responded that they experience inconvenience when moving. This quantitatively proves that the architectural structure chosen for aesthetics and communication has become an inconvenient obstacle that users must overcome every single day. We began to think about ways to resolve these inconveniences. We considered ways to address the inconveniences that users have felt and mentioned, as well as ways to preserve the feeling of courtyard that the original architect wanted. We conducted a mass study to find a way to maximize satisfaction of these two factors. In the process of mass study, many kinds of alternatives were presented. We thought about what should be prioritized in order to refine these rough ideas. The first key factor we considered is the sense of space in the courtyard. Reflecting this, three alternatives that do not undermine the existing sense of empathy were selected. The second key factor we considered is the environmental element caused by the courtyard. To take this into consideration, we directly used Rhino and Grasshopper to conduct environmental analysis and optimization. First, we analyzed how each option affects daylight in the central courtyard. Even if a bridge is added, the courtyard should not become too dark or lose its original light condition. To check this, we divided the courtyard floor into grids and compared how long direct sunlight reaches each grid. Second, we conducted an indoor daylight simulation. We checked whether each option makes the interior darker or reduces the quality of the light environment. So we compared how deeply daylight enters the inside and how much comfortable luminance is secret. Here, a higher UDI value was considered better because it means the indoor space remains comfortable for a longer time. Lastly, we use CFD analysis to check airflow through the central void. Since the void also supports ventilation and openness, an option that blocks airflow too much is not suitable. So, CFD was used as a pass or fail criterion, not as a numerical score. Options that significantly blocked airflow were excluded. This table summarizes the result of our courtyard daylight, indoor daylight, and void space analysis. The values marked in red, such as total void area, courtyard direct sun, and UDI, were considered better when they were higher. On the other hand, the value marked in blue, indoor direct sun hour, was considered better when it was lower. Based on this criteria, option 2 showed a larger void area, a higher UDI value, and a lower indoor direct sun hour. For this reason, we selected option 2 as the best option. So, one question comes up. If this bridge had been planned from the beginning, how will it be constructed? The answer is the lift-up solution. In this method, the bridge is first fabricated on the ground or at a lower level rather than assembled piece by piece in the air. Then, temporary supports and hydraulic drags lift the bridge slowly and evenly to its final position. Once it reaches the target height, it is connected to the main structure, such as the beams, columns, or megatruss system. This method reduces high altitude work, improves safety, and makes the construction process more controlled. Therefore, it can be a realistic method for installing a bridge inside the central void. Adding a bridge could shorten circulation routes and improve the overall usability of the space. Also, it is not technically impossible to build. However, in actual buildings, this kind of solution is not always applied. Then, what kind of relationship should have been considered? Design. Designers consider the building's concept and design intent. Client. Client considers construction costs and maintenance issues. Users. Users consider circulation routes and conveniences. Construction. Contractor considers construction methods, structural systems. In traditional processes, each group usually works separately. Then, is there a more efficient way to consider these factors together? First, IPD is a project delivery method that brings the client, designer, constructor, and users together from the early stage. IPD makes collective mindset easier to achieve. These perspectives overlap and influence each other. IPD helps integrate them early, allowing the project team to make more balanced and efficient decisions. As a second alternative, we propose PM, or Project Management. PM is a method of coordinating the needs of multiple stakeholders and managing projects within the existing construction process. It collects the needs of all stakeholders and organizes them on a basis of cost, schedule, quality, risk, and user convenience to make decisions. But as shown in the Amorepacific project team structure in Korea, it is difficult to apply these methods in practice. Each team has its own responsibility and contract relationship. Because of this, it is difficult for all stakeholders to work as one integrated team from the early stage. Korea may also need a system similar to IPD and PM by developing a Korean-style coordination process that considers cost, schedule, constructability, maintenance, and user experience together from the early stages. The design idea was based on Korean identity. The courtyard was inspired by the hanok, and the facade and louvers were inspired by the image of a moon jar. However, these design ideas also made construction difficult. The site was close to subway line 4, and the large voids required careful construction planning. For this reason, special construction methods were used. CIP and top-down construction helped make the work more efficient on the limited site. The megatruss and hanging floor systems also made the large open void possible. After completion, the building successfully created an open community space. However, during actual use, we found a circulation problem. The central void made some routes longer, so we tracked this issue through grasshopper simulation and user surveys. To solve this problem, we proposed a bridge alternative. We also checked courtyard daylight, indoor daylight, and airflow. Based on this process, we selected the most balanced option. Finally, this project taught us that architecture should not be judged from only one point of view. Design, cost, construction, maintenance, and user experience should be considered together through integrated thinking such as IPD or PM. Thank you for listening.